Welcome to Celestial Navigation 101. I'm your instructor, Rhett Lane. Okay, so we have two things that we have to deal with: longitude and latitude. So latitude is the easiest. To determine your latitude, really you just measure the angle of the North Star above the horizon, and that's it. Okay, so, and you can find the North Star. Here's the Big Dipper, and if you look at the two arms right here, they point to the end of the Little Dipper, and the end of the Little Dipper is the North Star, which is not very bright. That's a very common idea that the North Star is like super bright. It's not. Okay, that's why you need the Big Dipper to find it. So, if you measure an angle of 37.644 degrees, now if you want to get that into degrees and minutes, then you have to take 37 degrees and then multiply 0.644 degrees times 60 to get into minutes, and you get, actually this is the one, that's the location of Area 51. This is the location, if they measured 37.2 degrees, and you can convert that into minutes, so you take 0.2 divided by 60, and then that would give you this 12. I messed that up. Okay, so that definitely is 30, that's what you measure 37.2 degrees. To get the 12 minutes, you would take 0.2 times 60, and then you get the 12 minutes. So it's 3712, that's the location of MacGyver. Now, the only thing you can do next is to say, okay, Area 51 is at 3714, and this is at 3712. So this, Area 51, is further north than their location. So Area 51 is further north, so you need to go north-ish. Okay, so that's easy. That's what you measure with the sextant. Now, in order to measure the longitude, it's a little more difficult. Let's move over here. So longitude is measured with a clock. That's why they had this prize to make a clock that you could bring on a boat so you could determine your longitude. So if you know the time that a star is supposed to rise, and you measure the time, and the difference in time based on Greenwich Mean Time tells you your longitude. Okay, so I picked a constellation, Aquila, that you could see, and it would be at the same time, and measure when it rises. It rises at the local time of 1:48.632 a.m. That's where they're at. Okay. If you knew when that rose at Greenwich Mean Time, which you would know if you were observing, you would know that because it's important. It rises at 9:35.22 a.m. Okay, so I need the difference in these two times in minutes, and from the difference in those two times in minutes, I can get the longitude. So the first thing to do is convert this time into minutes. So it's 1 hour, that's 60 minutes, plus 48 minutes, plus 0.62632 of a minute. So I take 1 times 60, 48, plus 0.632 divided by 60, and I get 108.632 minutes. Now I need to do the same thing for this one. 9 times 60 plus 35 plus 0.22 divided by 60, I get 575.22 minutes. Now I need the difference in those times, because the difference in the time tells me my longitude. So I take this minus that, and I get 466.588 minutes. That is my longitude in minutes. I need to convert that to degrees by dividing this by 4. Actually, because it's a time difference. There's a 360 degrees around the world, but there's only 24 hours. So it's a conversion from time to angle measurement. So I take that minutes, divide by 4, I get 116.647 minutes. Now I can take that 0.64, convert that into a decimal degree into minutes, and I multiply it by 60, and I get 116.38 minutes, 0.82, or you could do that as 49 seconds if you want to convert that again. Now if I look at this, and it's actually negative because you're behind Greenwich Mean Time, so you know you're in the west. And that's actually Area 51 is negative 115. So this is more negative, this is more west than Area 51, so we need to go east in order to get there. So you need to go northeast to get to Area 51.